So, okay, good.
Go ahead, Sven.
Thanks. So, presentation is named An Introduction to ESGpull, Replacement for Cinder, and we're going to talk about all of these different points and probably skip over a few if it takes too much time, because I'm not sure I can fit in everything. So for starters, we will talk about why we did refactor Synda, and I think Atef already mentioned it a bit before. I didn't hear everything. Then go over the key features of ESGpull. And then I think the next one is one I will skip and we can talk about it in discussions. That's a technical overview of what is inside the code. Then a quick overview of the command line interface, but this would be more interesting to look at during the demo. And there's one slide on configurability, which, okay, can you hear me well?
Yeah, sounds great to me.
Okay. And then finally comes the demo, which is split into 3 parts. Unfortunately, I don't know if I will have time to go through everything. So the first part is going to be the most important one, and then we will go quickly about the next ones if I have no time or few time left. So I take too much time before. All right, so I took a quote from the Synda documentation, which goes, Synda is a command line tool to search and download files from the ESGF archive, which sums it up pretty well. So how does it work? I will just go back quickly about how Synda works, and then we can talk more about ESGpull. So the way it works is it starts with a request entered by the user, which is a bunch of search criterions. They are called facets, and they're the same facets used everywhere in the ESGF and the COG interface, for example, on Metagrid. And those facets could be set on command line or using a template, which is also known as a selection file. Synda gets this transforms this template into an HTTP request, which is sent to the ESGF index nodes, and those nodes respond with lists of files and datasets metadata. What Synda does with this list, it then saves it in a database. It's SQLite database, which works as memory for what it has to do, has done, and will do over multiple usage of the same command. And when you use the download command of Synda, it will take the queue of files that is currently in the database and download them and writes them to your local file system following the data reference syntax. So that's the whole gist of Synda, which is mostly the same for ESGpull. That's why I'm presenting it quickly. So now with the issues of Synda, there's quite a few, some more important, some less important, but the first one is just a general user interface experience. The fact that the command line is sometimes slow, sometimes confusing is, I think, a pain point for usage. And what I mean with slow or confusing is that sometimes it's actually slow and sometimes it's actually not slow, but there is like zero or little user feedback to the user, and so you don't know if it's slow or doing something. You might have an answer after 40 minutes of waiting. That's like one issue I found with Synda when I started looking into it. Then there's a few actions that have to be done outside of its interface. So that's one thing I did not really find friendly as well. I can think of 2 of those. That would be the login command, or not the login, the way to log into OpenID, such that you can download some files which are not public. You would have to open a file and enter your credentials to OpenID, but you have to know where that file is located first. You have the same kind of behavior for the configuration of Synda. You would have to find the file where the configuration is hosted and then modify that file directly. This doesn't help with experience. And on the other hand, on the developer view standpoint, you the code is very hard to understand, and it's also hard to maintain because of the way it's written, because of its history as well, as you can see on the GitHub contribution graph. There's been a lot of gaps in its development, and it's been developed by multiple different people, which each of them, if I'm not mistaken, have mostly just added some new stuff on top of what existed already, and that makes it even more confusing when you look at the code, because there might be some repetition in some functions or commands. Some commands might do the same thing, but they're not using the same code, and that would make it behave weird when you change one of them. And to add to that, there was zero unit testing, which doesn't help with trying to maintain the code, because whenever you change something, it would just break something which you could not know what it was before or what it should be. All of these issues are actually, I think, the main reason for refactoring. And there was just this one extra thing which I found interesting, is that Cinder would do inference on the requests the user inputs. Here I have a small example that I just ran this morning. If you search in Cinder for frequency equals day, then it would infer that to be actually a facet named time frequency. But whenever I add project equals simip6 to the exact same command, then it changes nothing. Like frequency stays frequency, but it doesn't become time frequency. And this is littered all over the code, and it's sometimes hard coded into, like with dictionaries from when the development of from when simip6 arrived, because Cinder was developed during the simip5 exercise. There was a lot of hard-coded facets, and then there was like this mapping from simip5 to simip6, and then there was this inverse mapping when people started using only simip6 facet names, etc., etc. And all of this led to the development of his ESGpull, like, because we needed a simpler, more maintainable, and more modern as well tool, which I will now present. Finally. So, because it's a successor to Synda, it has to do the same or almost the same stuff, and that's why it's designed primarily for data replication, because that was the main use and the main objective of Synda. So ESGpull has the same objective, but it also helps with data and metadata exploration or discovery, if you want to call it that way. And an extra feature is that it's a more modern command line interface, if that talks to you. What I mean with that is that it's got colors and it's a bit more responsive. There is feedback when you do something. And as an extra point, most of the latest Python standards are followed, like the code is 100% typed and checked with MyPy. There is flake 8, linting, black style. I put unit test using PyTest, but the code is not fully covered yet. This is due to the fact that the core library of ESGpull is covered, but the interface part is not 100% covered. Actually closer to 0% covered. Anyway, I put some links here, so to the GitHub repo and the documentation. You can get those on the slides that I will share after the presentation. So to get more deep, to dive deeper into the features, what it looks like inside. For replication, we decided that the objective was to give control to the user. And so for that, there's a few choices that have been made on the design parts, so that it's not specifically easier to use, but it's more controllable. And so for that, we decided that the query, which was called the request in the Synda image I showed before, the query is the central element, and everything goes through queries. And a query can be associated with files, which is obviously when you want to download some files. Data sets don't really exist in esgpull. They are still used for the search to be more friendly, but everything is query or files. And so data management is reduced to query management. You don't actually go over files. There is a little view of all the files except the size it takes on the disk and how many files there are. And to give more control as well, the workflow, which in Cinder used to be just install download, is now split into more steps. That's 4 steps actually, which are incremental. So to go to the next step, you have to go through the previous one. The first step is add. That's when you save a query to the database, which only saves it to the database, does not download anything, no metadata. Then you can track that query, which it's a simple safeguard to avoid downloading too many metadata by mistake. So it only changes the value of a Boolean flag so that the query can be associated with files and send actual requests to ESGF search APIs. And when a query is tracked, you can then update it using the update command, and that will actually fetch the metadata from files associated with that query. And then when that is done, you can download the files by using download. So that's most of it for the replication part. And then for the exploration, there's a bit of a messy bunch of features. Some of them are well defined, some of them are a bit less well defined. The facet search is the most obvious one. It's you just write facet : value, and that's using the actual values that you can find in the different projects and data sets. So for SemiPX, it's always the same facets. For SemiFi, it's always the same facet, but the facets are not the same between the 2 projects, as you probably already know. So you can use also multiple values for a facet. I think that also was the case in Synda, and it's exactly the same syntax. There's the ignore facet, which also is taken from Synda. That's when you don't want one specific facet. And there's this free text search, which actually is just offloading the text search to the Solr backend. So it's writing the query such that Solr can handle it, and then it just gives it to Solr and do whatever Solr wants to do with it. But that's also not esgpull feature. It's from Solr. There's the wildcard syntax where you just write wildcard in the middle of a value or free text search, and that will do expansion of that wildcard based on what exists in the index nodes. And the part which is actually from esgpull, that's all the little helper functionalities, which is also exploiting everything that's available from the search API, but in a nice and consistent way with everything else. So that's, for example, getting all the available facets for a query that you partially wrote. Also getting the values for that query, values for a facet that you want to know which values exist in that query. You can do date filtering and many other things that I hope I will have time to show in the demo. All right. Yeah, so here is a picture, but I don't think I will go through every single flag that exists, but it's everything you can do, plus the syntax, which is not documented in this command. But everything is described in the documentation, so you can always refer back to it. So yeah, I think this one I will skip because it's just enumerating all the libraries that are used in esgpull. It's basically SQL Alchemy with SQLite, and then asynchronous libraries for HTTP and file system. There's not much more to say about it. Unless you have questions later, we can discuss this. I also put a schema of the database, but it's not very important. So for the configuration, I don't think I will go over every single part, but this is the way the default configuration looks like. And the idea behind the config command is to give the opportunity for the user or data manager that uses esgpull to tailor the tool so that it suits its own need, their own need. So, for example, in the download section, you can change the size of a chunk that is downloaded. That's because download happens chunk by chunk. Here, the default value is, I think it's 64 megabytes. And you have this max concurrent just next to it, 2 lines below. This is the number of concurrent workers that are going to download files at the same time in a synchronous way. And basically, for example, these two can be used to limit the amount of RAM you want to use during download, because it's always going to be at most 5 times the chunk size, all held in memory, and then it's written to the file system. So yeah, there's many options that you can change. The default index nodes that you want to hit when you run a search command, etc., etc. I don't think I will describe everything. For the command line interface, so here are a few screenshots of what it looks like to use esgpull. I also will not describe everything thoroughly because we will see that in the demo, but I put a few screenshots here so we have some support material to discuss for question time. So that's what the search looks like. It's pretty much the same as a Synda, or actually the same as COG. It just gives you the first 20 datasets, a number of files per dataset in the second column, and the size of the dataset. It's a very simple view. You can use the -- detail command flag, which if you want to know more about the first dataset here, is you get its ID on the left. You just write -- detail 0, and it gives you all the metadata on that particular dataset. It's basically the same as using the show more metadata on the COG interface. You can also output that as JSON. The YAML flag also exists, so most of the commands are outputable in a JSON or YAML format, so that you can easily plug the esgpull output, or actually mostly the search output, in another program. And this is the view of when you look at the list of queries that you have in the database currently. So this is an example from my own computer. That's why nothing is downloaded. Everything is 0 bytes because I don't have that much space. So that's just how it looks when you already saved queries and you want to look at them. This is probably the view that is the most used for data management. Then you have the status view. This one is actually coming from real usage of esgpull. So there's lots of info on there. I won't describe everything. And yeah, so for the perspectives of what comes in the future, short term, we hope to be able to release a 1.0 version as soon as all of the remaining issues are fixed. There's a few of them I discovered writing this presentation also. I think I heard talks about integration with Metagrid, or in any direction, esgpull outputting a Metagrid input, or the other way around. I'm not sure exactly, but we can always do this as a short-term goal, because I don't think there's much work to do to be able to fulfill this goal. And in a more long-term perspective, I think I heard also that people have issues with the wget script that is generated by the search API and the COG interface. So I think it's possible to propose esgpull as an alternative to that. The main drawback I would see is the whole Python and Conda packaging, which if people are used to not having Python or not using Conda, that's maybe a bit of an upgrade on the load of the number of things needed to be done to run one script. But if we improve on that, it could be a nice solution. And also make esgpull friendlier to a wide range of user types, so that we can get more feedback from many more users and improve on the default configuration, a lot more many things. So yeah, I think I nailed not taking too much time, so we will have time for longer demo. So demo is split into 3 parts, and the first one is going through setup and replication. And I will now go to my terminal if that works. Please tell me if I need to zoom a bit more, because I try to make it as big as possible. Yeah, so first thing I want to show is how to install it, but I'm not actually going to run it because it's already installed on my computer. But the installation is pretty simple if you use Conda. It's about the same if you use pip. It's just pip install esgpull without all of these environment stuff. So I'm not going to run it. So the first thing you see when you run esgpull is the help command. And here you can see a little description about each of the commands. And for reference, I'm just going to show my version here. Okay. One thing that is nice to look at first is the configuration, which if you run it as the first thing, it will give you an error that there is no installation, which there's also a little example of what you should do at this point. So you can go with the first one to see what installation already exists. Usually there should be none, but I have a few ones because this is my development computer. We're going to create a new one running this second command, and this gives a prompt with a default location, which I'm not going to use. I'm just going to use demo because that's a demo. Name is optional. It's actually a bit useless, but you can provide the name to that environment. And here it created a folder called demo in the current working directory where I'm at. And this, oh, no, that's not what I want to show. This demo folder is actually pretty much empty. There's just a default database in it and a few folders that are useful for esgpull. So just to be exhaustive, I will just show you how to delete an environment. It's simply self-delete. And this will remove the environment from the list of managed environments that you could see before in the choose command. Its name should be show, but you should not worry about it. And here our demo environment is not here because I just deleted it, but the folder is still here. Like it deleted nothing on the file system, and this is made such that there is no mistake deletes. Most of the deletion has to be still done manually because I'm not, I didn't find a nice way to delete stuff. And so to avoid any mistake, there is no deletion, some addition. Right, so we can just install it again. I can just put the name here to avoid the prompt. Okay, we can run again the config to see what's in the configuration. And it's basically the same as I showed in the presentation config. These are all default values, and I'm going to change a few ones that are, as I found later, and I didn't change in the default in the code. The page limit one here in the API section is actually very, very low, and it's basically the value that is it's the number of datasets that are fetched in one request to the search API, and 50 is making a lot of round trips to the servers. Usually a value like 1000 makes it much faster. And I also want to have default options in the API section. These are basically options that are applied to any query when that query doesn't specify options. So you can have options in query, and when you don't specify it, these are the ones that are used, which are configurable. And I want this to be true so that it always hits all of the index nodes. The default being false is probably not a good default. That was the next one. Okay, so now the config is ready for the demo, and I want to show you how to import Synda database. If you were a Cinder user, you probably already have a Cinder database. So here I have an example database. It's only it only has 2 files, so it's not taking too much time. And it's as simple as calling this command self import Synda and then path to your Synda database. It will scan the DB for the number of files and then ask you if you want to import those. And then when they are imported, you can look at the show command, which prints the query that are saved in the database, and it's empty by default. But now we have this legacy query, which is created only with import Synda. This is not possible to create otherwise, because here is the name of a query is a hash, except for the legacy one. So yeah, I just wanted to show that it's possible to import a database from Synda, so that the transition is as smooth as possible, Then I will create a new query, which is, I will create this query here. Let's search. That's not what I wanted to do. But it's actually a good example to show that the search and add command are using the exact same syntax. So you can explore the index, the ESGF index, and when you find a decent enough result, you can just add that one to the database. So this is now in the database. You can see it shows in the show command. And it's by default untracked. That means if you update, it doesn't do anything. It's a placeholder query, you can say. And it's got all the fields that we put, so that's as expected. And what I want to show is how to do how to use this require flag. It's basically for creating queries that inherit from another query, which is something I didn't know would be that useful, but it's actually very useful as a debug tool. When you have a query that doesn't work, you can inherit from that not working query and add, for example, ignore a specific data node that doesn't work at the moment and download those files until the data node is fixed. So I will create 2 queries, one with member ID R3, I1, etc., and another one with R2, which I will show the -- track flag. This is because the default is that a query is untracked, and when you -- track, it goes, it adds a query directed tracked. And what tracked is that when you run the update command, only tracked queries can be updated. And you probably notice that it also added these 4 lines that were not on the first one. These are the options that we saw before in the API default options. Basically, when you track a query, because there is this configuration options for defaults, if you have a query that's taking the values from the option, from the configuration, it could change over time. If you, for example, change your configuration and change this loop from false to true, then the result of that query would change. And because we want that a query in the database is always going to give the same answer unless there is new published data sets, as soon as the query is tracked, it's going to be setting its options either to whatever option you provide or the default ones, which is why we put this loop true in the configuration. And so now I think I forgot to track the other one. So we can also track that one using the track command, which is the default route to track. And so to do that, I will use the query ID, which is here. And this ID is unique because it's a hash made from the content of the query. And to make it not too hard to use, I put like a smart search, which will match the characters one by one, so that you don't have to put the whole thing. So if I do track 16, there's only one thing that should match, and that's this one. And so it prompts with a question for whether you want to add these as default options or not. It's most of the time it's a yes. And And now, if I'm not mistaken, both of these are tracked. And I can go to the update section, which is the next logical step. So you just logical step. You take a query ID and you can update it, or you can just update everything at once. That's basically taking all the tracked queries in the database and saying, I want the metadata for all of these queries. And if there are new files, put them in the download queue. But so it doesn't take too long. I will only update one of them. And it first hits with a message about how many files it's going to get. So that you know what it's doing and why it's taking more time. And here it's already done. We have the first message was giving us a hint of about 10,000 files, and now we know we see there's only about 3,000 files. This is basically because all the replicas have been deduplicated, removed, and we can send those to the download queue. And this is probably the longest part of the demo, where we have to wait. And there's nothing we can do about this because it's adding all the files to the database. And SQLite is not really suited for writes. That's how it is. And as soon as just a bit of water. As soon as the download queue is not empty, you can use the download command, which will go over the whole list of queries that are tracked, and then get from those the files that are currently not downloaded. I will cancel it so it doesn't kill my internet connection. But just to give you a little view of what it does when you download, it's actually blocking. So if you Control-C, it stops the downloads. It's not working as Cinder was doing, which was a daemon. This was removed so that it can, I mean, there's no big reason about it, but it's always possible to change that behavior. It's not imposed, but you can always use, up, I think is the name, and run it as background. That works well. I have two more things I want to show you for this part of the demo, and that's the status command, which is showing a summary of the status of all the files. Here, there's only one query, so it doesn't really look that good. But when you have multiple queries, it shows the status per query, and per status per query. It's like a three-dimensional table. And when files are canceled or in the error status, you can just go retry, and then those are put back in the queue, and you can download them again after putting back to the queue some files. And I think I'm just missing this one part, which is about how to import selection files. And what I mean by that is if you use Synda, you probably have a database, which I already showed how to import the database, but you probably also have a folder full of selection files, which probably looks like this. And this is the syntax used in Synda to do something similar to the query of esgpull, which is now in the database instead of in the file. And if you have a list of those that you use to replicate regularly to find new data sets and get the latest publications, you can still use it by using the convert command. And then it's going to give an error because I need to select display option. So let's use table. The convert command is not fully working for every single possible selection file because the Synda syntax was so complex that some selection files won't be converted properly. but most of the regular ones that I found were used here at IPSL. I think 100% of them are convertible. So if you use regular syntaxes, it should be working very well. So what it does, it takes every single line and creates the equivalent syntax for esgpull. And whenever it finds this kind of syntax, such as variable, and then precise for here table ID, and then you have a list of variable, it will actually translate that to a list of subqueries that inherit from the base one, which is defined from all the other facets. And so the conversion of this selection file looks like what you have on the right. And to use this in esgpull, because this is only done in memory, you can use the out, and this is going to print it in the YAML format, because this is the, I guess, the standard way of using esgpull as a I don't know how to say that, but anyway. So when you have this file, you can look at it. It's just this big YAML file, which uses a syntax that is not designed to be written by hand. It's usually only output from esgpull. And this you can use directly with the add command using a flag, which is -- query file. And I just use the Synda YAML file I just created. I will take all of these queries, add them to the database, and now we can go back to the show command, which prints out the whole database. And here we have the query we created before and updated, the legacy query with the Synda files, and we have here the files the queries we just converted at the top. So that's it for the first demo, the first part of the demo. The next one is exploring the search command. I don't have a specific script for that one, so I think I will just go through a few of the features that are usable in the search command. So the first one is obviously the how did I call that? The facet search. That's when you put facet : value. In Synda, it used to be like equals, but I decided to go with a colon. No reason for that. So this works exactly as expected. There is no modification of what you input. So if I use try run, similarly to what Synda used to do, you can see the URL of this search. And where is it? Here in the middle, you see project is Synapse. It's a bit hidden here. Yeah. There is no inference as Synda used to do. So everything you write is the exact way it will be sent to the index nodes. So the second thing that I talked about in the presentation was using multiple values. So that's the way you do it in esgpull. That's just separating them with a comma. I went with the comma syntax because, if I'm not mistaken, there is 0 facet value that uses a comma. Every single symbol that can be used is usually dash and underscore and dot. So comma is the separator for facets. If you add a space here, it will not work properly, unfortunately. The next one that I talked about is the free text search. So for example, if I use surface temperature, I have to put them in quotes, otherwise Solar will, I think actually this doesn't really work the way it does, because this is offloaded to Solar, and the way Solar works is that space is equivalent to the OR logical operator. So to have this work as expected, I created this special syntax where you replace quotes with forward slashes, and this will actually search for surface temperature in that order. And to showcase that it works, I use this -0. I think -0 works. 0 is just saying I don't want to see any table. I just want to see the number of data set returned by the search command. And so if I use surface temperature with quotes, it's going to be about 10 times more because it's looking for surface or temperature. That's why I created this weird / syntax to search for surface and temperature. So what we can use this for is then using the -- hints flag, which is basically exploiting this part of the output sent back by the ESGF search API, which is called facet counts. It's basically used for cog interface to show the number of values per facet value, but the number of dataset per facet value in the left panel. So you can also use it here in the esgpull -- hints. So it shows us for the query I just wrote. These are all the variable long names I can find, which is a bit more expressive than using variable. For someone that doesn't know much about climate like me, when I looked at this the first time, I was like, what is this? What are all those values? What do they mean? So I use variable long name as a more expressive one. What else do we have here? I also can show you the from and to. These are flags that are just date filters. So if you have this, we have using this query, we have like this 350,000 data sets. And if I do from say 2022, the syntax is just year, month, day. We should have less. So only 50,000. And you have the same thing working with 2. And so I think, if I'm not mistaken, it should be about 300,000. Yeah. So I don't think I have much more to explain about the search command. Like most of it is described in the documentation. If you want to find more about the syntax, there's not much more that comes to my head right now. But I can just show you how to look for a very specific thing. I use this query to find like one specific data set, and it uses the / syntax because otherwise Solr is doing random things with the query I enter. If I know exactly one data set ID, I want to search for it, I use this kind of query. And given this query, I can use this -- show flag, which shows what the query would look like if it was in the database. And what is this used for? It's when you then use the JSON format. This is a segue into the next demo. I can take this JSON, copy it, and then we can go directly to the next part in this notebook where I have prepared a few bits. So what this notebook is it's gonna do is present how esgpull can be used as a Python library as well as a command line interface. And so the one issue with this is it's currently undocumented, but I'm hoping that the code is easy enough to be read so that people can mess with it, play with it, and it should get documented as soon as the API is stable. So yeah, the imports are pretty easy, just esgpull and query. I will create this query using the JSON I just copied from my terminal. We can print the same way as in the terminal using the rich library. This is not mandatory at all. So just print the query. It's looking as a Python object. To create an esgpull instance, I simply use esgpull. Create an instance of the class esgpull, and it's going to use the path that is currently set in our self choose command. So this is a global configuration command. Now, if I want to look for the files that this query returns, I can use this context.files. Context has actually should be named search, but it's I set this name at some point and then never change it again. So esg.context.files is sending a query to the index nodes using the default config, and it's using this queue object, which is the query I just copied from the command line. I use keep duplicates equal false because the default value is true, and it's messing with the download in the notebook. So it should not be required, but it's currently required. So if I run this, we get 4 files as expected from the command line. It was 4 files per dataset. And I can download using this esg.download and then files. Also another flag that it should not be necessary, but I don't want to put those files in the database, so I use db equal false, and this is just going to download the files, put them in the correct spot in the file system, but it's not going to add them to the database, so you can use the library without impacting your current installation of esgpull. And here it should be not too slow. And otherwise, I prepare the environment where the files are already downloaded. I'm just going to let this run because it's actually quite fast. Not so fast. Okay. Let me just use this ESGF demo folder and it's demo 3 back. Click files, and here is a that's not on the web. Oh, that's a demo effect, I think. Oh no, I know why. I know exactly why. Let me just fix this quickly. I think that's it. It's because I did not change the configuration to use distributed queries by default. Just a mistake on my part. Yeah, I go. Default distribute. Now it should be working. Yeah, okay. Small mistake. And so now, because the files are already downloaded in that environment, it downloads 0 files. Because it would be pointless to download again the files that already exist on the file system. We can get, okay, so that's not what I want to say. Yeah, we can get the path to the files by using this fs object, it's file system, and get path of the file, and this will happen the name, but the path to the current location of the location of the current installation and data folder to the path that it is actually in the file. So you can see in the file that path only includes the DRS data reference syntax part. And then I can directly use it in Xarray using OpenMF datasets and a list of the path for each of the files I just downloaded. And this works as it should. And then I just created a few means of I think it's monthly mean and 5-year mean, and you can see it's easy enough that there's not much to be written with the esgpull, and as soon as the downloads are happening, then you can use your netcdfs as you would, which I'm not a scientist, so I would not know how to do it exactly. It's just an example. Okay, so that's it. Thanks for listening, and if you have questions, I think that would be the time now, if we have time.